Hello everyone, good evening. Today we will start, you know, the session of electrical measurement. So this is the last week where we will discuss electrical measurements and electronic instrument. Last week we saw the concept of Lissajous pattern and we solved a couple of questions based on that, right? So we went through all the concepts of, you know, plotting of y versus x. We took each cases with each angle, you know, for the cases of circle, straight line, ellipses. So till 0 to 360 degree, we saw all the plots, right? So today we are going to see some problems again based on that. Okay, so this was asked in this week's assignment or previous week's assignment. I hope you must have gone through it. So in this problem, we need to find out the frequency of Vy. So how to find out the frequency of Vy? So as I told you that Fx by Fy is equal to number of tangencies in vertical direction divided by number of tangencies horizontal direction. Okay, so from this figure, if you have to draw a tangency that should cut maximum portion of this curve. Okay. So how many cut is there? 1, 2, 3, 4, 5, 6. Okay. So vertical directions, there are 6 tangencies, right? And how much in horizontal? So if you select anyone, so there will be 2 cuts, right? 2 tangencies. So it is 2. So Fx by Fy will come out to be 3. So the frequency of Vy will be Vx by 3, and Vx frequency is given 100 Hz. So the answer would be 33.3 Hz. Okay, I hope it is fine. Right. Now, another question was asked in that week's assignment was, yeah. So this was the another Lissajous pattern. We needed to find out the frequency of Vy. So we will do the same thing again. So maximum tangencies will be drawn in such a way that it should cut the maximum times, right? So if I draw it, I think that should be maximum. Maximum of vertical tangencies should be 3, right? 1, 2, 3. Or yeah, yeah, it should be 3, right? And how many horizontal cuts will be there? I think it should be 4, right? So maximum times is 4, right? So again, Fx by Fy is equal to number of vertical tangencies divided by number of horizontal tangencies. Right? So it will be equal to vertical tangencies are 3, right? So this is 3, this is 4, and fx is given, right? Fx is 100 given. So we just need to calculate fy, right? So fy will be 4 by 3 into 100. So it should be equal to 133.33. Okay, I hope it is fine with you guys. Yeah. So let us proceed to the next part. Yeah, this problem. So this is a linear ohmmeter circuit, isn't it? And we can assume that beta value is very high, and input impedance of the voltmeter is also very high, right? So we need to find out the value of Rx if voltmeter reads 2.2 volt. Okay, so instead of NPN transistor, this is a PNP transistor, isn't it? So here VBE is given 0.7 volt. We need to find out this Rx. Okay, how can we find out this Rx if we know the current in this branch and voltage of that branch, right? So voltmeter across the Rx is connected, and that voltmeter will read the voltage across the Rx. So V is given 2.2 volt. The only thing remains is calculation of current in that branch. Okay, so how much current is flowing here, which is essentially which current, collector current or emitter current? The current that will flow through Rx, which current will be that, collector or emitter?
The collector current.
Excellent, that will be collector current because it is a PNP transistor, right? So we just need to find out the collector current. Okay. And will collector current be equal to emitter current? If I am saying collector current is equal to emitter current, will that be right? Because
No, sir. Beta plus 1.
yeah, go ahead, please. Yes.
Sir, IE is equal to beta plus 1 into IC.
Exactly. So IE is equal to beta plus 1, what, IB, right?
No, sir. IB.
See, IE is generally IC plus IB, right? And IC is nothing but beta IB plus IB. So it will be IB 1 plus beta. Is that correct?
Yes, sir.
Yeah. So in this problem itself, it is saying that assume the beta value of BJT to be very high. Okay. Then what does that imply? If beta value is very high, which means IB will be almost equal to 0. We can assume IB to be 0. Why? Because, no, E is equal to IC plus IB. And if you want to find out the value of IB, that will be IE minus IC, right? So IB is nothing but the difference between emitter and collector current. Okay, and that is nothing but the base current. Okay, and if you try to, if it is given beta value of the BJT is very high, which means If you manipulate this equation, you will get IB almost equal to 0, which means IE is equal to IC. Is that fine? So that was a clue given for this particular problem, that we needed to find out IC for the calculation of Rx, right? And we do not know the value of IC. If somehow we can calculate the value of emitter current, then indirectly we know the value of collector current, right? So for that, how to calculate that emitter current? So this 15 volt will be distributed among these two resistors according to the voltage division rule. So if we divide this 15 volt, so can I write it in this fashion: 5.7 volt and 9.3 volt? Have I written correctly? Because this 15 volt has to be divided among these two resistors, right? So if you add 930 plus 570, the ratio of them, if you like, how much the V1, this is V1, V1 will
So
be,
9 point,
yeah, sorry,
सर वो वोल्टेज जो है गेट वोल्टेज वो तो मैं सॉरी जो आउटपुट वोल्टेज होगा जो
mm-hmm.
डिवाइडर का पोटेंशियल 3.3 वोल्ट होगा ना
3.3
नो
है
सर
ना,
9.3
9.3, हाँ ये 9.3 तो है.
फिर यहाँ 2.2 कैसे आया
2.2 is this voltage, see, this voltage is 2.2, which is, let me, that will be, this voltage plus drop. There will be some drop between base and collector, right? That value we are not given with. We are given with only the value of VBE, not VBC. Are you getting my point? Whatever this 9.3 volt is there, that will not be directly reflected to the voltmeter, right? So that has to be adjusted. That is why it is linear ohm meter, right? Okay, is it fine? को ड्रॉप नहीं मिस करना है, ये ड्रॉप दिख नहीं रहा है, बट दैट ड्रॉप विल बी देयर, राइट? Okay, okay, fine. So, and according to according to voltage division rule, you can calculate V1, that will be nothing but 15 into 570 divided by 570 plus 930. So you will get V1 is equal to 5.7 volt. Similarly, V2 you will get 15 into 930 divided by 930 plus 570. So you will get 9.3 volt. Okay. So you'll get V1, V2 like this fashion, right? Now, the only thing is to find out this current, this voltage and this current. That will be IE. Okay. In that fashion, IE will flow, right? IE will be equal to IB plus IC, because this is a PNP transistor. Okay. So now we have this voltage 5.7. Now we can apply a KVL here, right? If we can apply KVL, how much will be this voltage? Let's call it, Vx. Okay. across this 10,000 ohm resistor. So Vx will be 5.7 minus this VE drop, right? That will be 0.7 volt, which will be equal to 5 volt, isn't it? Are you following till now, Sangeeta?
Yes, sir.
Okay. So that is 5 volt. Now we have calculated this voltage. If we divide it by 10,000 ohm resistor, that will be our IE current, right? So IE will be nothing but Vx divided by 10 kilo ohm. Vx is nothing but 5 volt divided by 10 kilo ohm. 0.5 milliampere. Okay. So this is IE is 0.5 milliampere. And since beta value is very high, that will be equal to IC. Okay. And now we have all the values IC and this voltmeter reading. So can we calculate Rx value? Rx will be this voltmeter reading divided by this IC, which will be 2.2 volt divided by 0.5 milliamp. Okay, so Rx will be how much? 4.4 into 10 raised to power 3. So 4400 ohm, 4.4 kilo. Okay, is there any doubt in this question?
No, sir.
Okay, great. So let's move on to the next question. Okay. Again, I think based on one Lissajous pattern is there. Yeah. So this question is based on again Lissajous pattern. So again, we need to find out the frequency of x-axis voltage. We are given the frequency of y-axis voltage. Okay. So again, we will do the same thing. Fy by fx equal to horizontal tangencies divided by vertical tangency. Okay. So how many horizontal tangencies are there? We have to select so that it should be maximum, right? So 1, 2, 3, 4, 5, 6, 7, 8. Horizontal tangencies are coming out to be 8. Okay. Let me know if there's some mistake done by me. Okay. And so, yeah. So now we need to calculate the vertical tangencies. So vertical tangencies will be like this: 1, 2, 3, 4, 5, 6. So that is coming out to be 6. I hope it is correct. Okay. 1, 2, 3, 1, 2, 3. Yeah, 6 only. So it will be 6. Okay. Right. So if you have gone through this Lissajous pattern lecture last week, you might be understanding that why I am cutting so that maximum tangency should be arise in the path. Right. So if y is given 200 hertz, it is 200 hertz. We need to calculate fx, right? So fx should be 200 into 6 by 8. Okay. So how much will be there? How much frequencies will be there?
150.
150. 150. Exactly 150 hertz. Yeah. So this is how we solve problems based on Lissajous pattern, right? Any doubt in this part?
Sir, I have one doubt here.
Yeah.
If I consider vertical tangent, vertical line,
Mm-hmm.
so if I take at the edge, if it is a half, if
Yeah.
it is a C shape,
Ha, ha,
so
ha.
then how can we measure, sir?
Okay. So you are saying that if you are considering only edges, right? Let me get your question first. You are saying if you only consider these edges, right?
Yes, sir.
Then you will get different value. That should not be correct. Okay. Because
Oh,
from the definition of Lissajous pattern only, the maximum cut should be there in your tangencies.
okay, okay, sir.
Okay.
Okay.
Yeah. Nice question. Yeah. Any other question in that? Okay. So let's move to the next part. Yeah. So this is a emitter follower voltmeter circuit, right? Here all the parameters are given. VCC, full scale deflection current of PMMC meter is 5 milliampere, and PMMC internal resistance is also mentioned. Okay. And this BJT has VBE of 0.65 volt. Okay. So this drop is 0.65 volt. Okay. And beta is also finite, that is 249. Right. Now, first thing we want to find out is the value of RS to obtain full scale deflection if V in is 5 volt. So if V in is 5 volt, okay, we need to find out the value of RS for full scale deflection of PMMC. Okay, we have studied PMMC earlier, right? So it should not be tough for us. So what should be our approach for this problem? First, we should draw or we should find out a KVL equation, right? So what will be that equation? V in is equal to VB in plus IERS plus IE into R meter. Okay. So we have included all the terms, right? Now, full scale deflection current of PMMC meter is 5 milliampere. Okay, so if we are asked at the full scale deflection condition, we can consider that 5 milliampere of current as IE, right? So IE we can consider as 5 milliampere, right? And RM is given, that is 200 ohm, VB is 0.65, and V in is 5 volt. We need to find out this RS value only. Okay. So I hope now it is straightforward for us. So RS plus 200 is equal to 5 minus 0.65 divided by 5 milliampere. Okay, so it should be 0.65, 4.35 divided by 5 and 1000. Okay, so RS should be equal to, and yeah, RS will be that minus 200. Okay, 200 also we have to consider. So that will be 4.35. So that is 870 minus 200. So it is 670 ohm. Okay. So that answer should be 670. Any doubt in this question? Okay. If no doubt is there, then it has other part as well. Part two. Now this time we need to find out the meter deflection. Okay. For V in is equal to 2.5 volt. Okay. For the same value of RS. So can we calculate that? How much meter will be deflected? To get deflection, which means we have to indirectly calculate that emitter current, because emitter current will only be reflected with this PMMC, and how much that is the ratio of our full scale current, that will be the percentage of deflection, isn't it? So V in now we have to change. So again, I'll write the same equation. V in is equal to VBE plus IERS plus RN. Okay. So this time we are given with V in as 2.5 volt. Okay, VB is still same 0.65. IE we don't know. RS we just calculated 670 and RM is 200. Can we calculate IE now? Right? So IE will be 2.5 minus 0.65 divided by 870. So how much will that current be? So it will be 2.12 milliampere. Okay. So will that be answer? No, still we have to calculate the percentage of deflection with respect to full scale deflection, right? So percentage deflection is 2.12 divided by 5 into 100%. Okay, so now it will be 0.2142, 42.4% it should be. Okay, so that much percentage of deflection will be there if you'll change your input voltage, right? So that is why the circuit is emitter follower voltmeter circuit. If you change your voltage, supply voltage there, okay, which is connected from base to emitter, then your current will also change, right? Any doubt in this part? Okay, if no doubt is there, let's move on. So last week we saw, 6 different kind of Lissajous pattern that falls in between different that falls in for different phase angle, right? So we have a matching problem, right? So that problem will be based on like this. We need to tell how much phase angle will be there. Okay, from y to x, vy, vx. Okay. So can we parallelly, you know, find out the angle between Vy and Vx? Let's suppose Vx is Vm sine omega t and Vy is Vm sine omega t plus phi. Okay, right? Or omega, these frequencies could also vary depending on how many ellipses are there, right? If there are multiple ellipses, then we again have to do the tangencies analysis, and based on that, it can change, right? As of now, we have only one, locus or loci, you can say. But as it becomes locus of multiple curves, then you also need to take care of these frequencies, right? Omega 1t, omega 2t. Okay. So for this kind of a straight line, what is the phase there? What is the phase difference between y and x? For the straight line, I simplified in last week's lecture as well. For a straight line, only there are two scenarios, either 0 degree or 180 degrees, right? So, if you will plot with respect to time, right? This is Vy, okay, or Vx. You can say anything. If you want to, draw the Vy with respect to time, so Vy is equal to Vx at all the instances. So it will superpose this waveform, right? This curve will be y is equal to x. Okay. So if it is lying in first and third quadrant, it is its phase is 0. But once it lies in this quadrant, right? Second and fourth, then what will happen? How much will be phase difference between Vy and Vx? Now for this, y is equal to minus x, isn't it? So the next curve will be like this. So now from waveform also you could see that this phase shift is 180 degree, isn't it? That is why I was saying that only two cases persist for a straight line, either 0 degree or 180 degree, right? Any question here? If not, then can we find out the phase difference for this ellipse? Just a second. How much will be phase difference between Vy and Vx for this ellipse? Or range would be fine. Actually, we cannot calculate exact. Exact we can calculate if magnitudes are provided. Okay, if magnitudes are provided, then we can calculate exact value. So the direction of the locus is clockwise. Okay. So this clockwise, when clockwise happens, then phase lies between which angle? Ninety to 180. Okay. Had it been in the first quadrant, this is how any Lissajous pattern will be, combination of multiple locus. Okay. So if it is in first quadrant, it will be 0 to 90 degree, isn't it? If it shifts to second quadrant, then phase will be 90 to 180. Okay. And if this is for clockwise, if it changes to anti-clockwise, then what will happen? 90 to 180 case, this is for second quadrant, right? Second and fourth. Mhm. Second and fourth quadrant. This is first and third. Okay. If this phase will move to 180 to 270, okay, we are talking about ellipse only, right? Then the quadrant will be still second and fourth. Okay. And if phi lies between 270 to 360, then it will again be first and third. Okay. So now we know all the cases. Okay. I'll ask some questions from you. You'll have to let me know the phase difference range. Okay. So, so what will be the phase difference between these two Vy and Vx? Can you please let me know? And to make the question more interesting, that type of question could come in exam. That's for sure. If I will also provide you this value, you know, let's suppose it is 1 and it is 1 by root 2. Okay. Now you have to tell me, exact phase difference between both the angles.
Forty-five degrees.
45 degree. 45 degree, you are partially correct, Mr. Reddy. You are
Yes.
partially correct. You did not take care of the direction. Direction
Okay.
is anti-clockwise. Okay.
Okay, sir.
So for anti-clockwise, what did I say? It will be for anti-clockwise and first and third quadrant.
Okay.
So
270 to 3.
270 to 360. So that angle is correct. That is sine inverse 1 by root 2 divided by 1. This magnitude divided by this magnitude. But that will be 360 minus that, right?
Okay.
So 360 degree minus 45 degree. So it will be 315 degree.
315 degrees.
Okay,
Okay, sir.
great. Let's take another case. Okay. Consider this as a circle, please. Okay, this is looking like ellipse. Let me draw a circle. Vy, Vx. Okay. The circle is going in that fashion. So now I need to know the angle between Vy and Vx. How much will be angle? So if you can't recall, maybe you might have remembered it, or anyhow you forgot. Okay, at any instance of time. So what should you do? You should try to plot it. You know, considering different points, right? So at Vx is equal to 0. Okay, Vy is maximum, right? Let's suppose this magnitude is maximum. Its radius is a. The radius of this circle is a. Okay. So let's suppose you have forgot at any point of time. So at Vx is equal to 0, Vy is a. Okay. At any other time, at you know Vx is a, then Vy will be at this instance, Vy will be 0. Okay. So if you try to, if and it will have only in sinusoidal form. So if Vx is Vm sine omega t, then Vy will be how much phase shifted from Vx?
90 degrees.
90 degree. Exactly. Excellent. So why 90 degree? So because, you know, when sine is 1, cos is 0. When cos is 1, sine is 0.
90.
So it must have to be 90 degree. So Vm cos omega t. Okay. So 90 degree. So that is how you could have calculated it. Okay. Now, in this problem, if I reverse the direction, now it is anti-clockwise. How much will be angle?
270 degree.
270 degree. Excellent. That will be 270. Yeah, yeah. You were saying something, Sangeeta?
नहीं सर वही 360 माइनस 90 करके 270 बोलो.
Exactly. Yeah, that is another way. Yeah, yeah, that is another way. Yeah, right. So for anti-clockwise, phi will be 360 minus 90. So that is 270. Otherwise, what you could do with respect to time, what is happening? So consider t is equal to 0, draw one plot. Okay, consider t is equal to t1 with increment in time, t2 because it is moving in anti-clockwise direction, and you see that Vy is lagging Vx or Vy is leading Vx. Okay, you will get the idea by that way as well. Okay, I hope you are getting my point. Okay, so let's see some problem based on that.
तो सर ये एंटी क्लॉकवाइज को लैगिंग मान के चलेंगे और क्लॉकवाइज को लीडिंग मान के चलेंगे क्या?
Uh, yeah, that's a very good question. So see, agar if you are moving towards anti-clockwise, okay, so with time, how will it be plotted? So let's see on time plot as well. Okay, so consider at t is equal to 0, Vx at t is equal to 0, Vx is equal to A and Vy is equal to 0. Okay, so if you plot Vx and Vy, Vx is equal to A, this point, Vy is equal to 0. Okay, now if you move further at t1, here you are coming, at t1 Vx is 0, right? At t1 Vx is 0 and Vy is maximum, that is A, right? So like this, like this. Okay. Similarly, it will follow if you move along the line, along in the direction mentioned in the problem, you will see like this. Okay. So there is certainly phase difference of 90 degree, but which one is lagging? From this curve, you can let me know which one is lagging to which. By just seeing this curve, this zero crossing and this maximum, which one is lagging or which one is leading? You tell me.
So Vy curve is lagging and Vx is leading by Vy.
Excellent. So Vy is lagging by 90 degree, right? Which means Vy is leading by 270 degree. Is that fine? So here this phi is nothing but how much angle this Vy is leading by Vx. So Vy is lagging by 90 degree, that you agree, right?
Yes
Sangeeta?
sir.
Ha. So Vy is lagging by 90 degree. In other terms, if Vy is lagging by 90 degree, it will lead by 360 minus 90, right? So 270 degree. Okay. And same thing you perform for clockwise direction as well. Okay. After this session, you perform the same graphical analysis for clockwise. Or let me do it for you here itself. Okay. So if clockwise is there, so they will be like that. Okay. So we have to move according to any according to clockwise direction, but you can start from any point, right? So take this point at t is equal to 0, right? So at t is equal to 0, Vy is maximum. Okay, Vy is maximum, and Vx is 0. Okay, so these 2 points are there. Let me take different color. So Vx is at this point, Vy is at this point. Okay. Now you move along the direction. You came here at t is equal to t1. Okay. Now Vx is maximum and Vy is 0. Okay. Now you connect the dots. It will follow similar to this curve. Okay. Now you tell me which one is lagging to which by how much angle.
Now Vx is lagging by Vy by
Uh,
90 degree.
yeah, so Vx is lagging by Vy by 90 degree. It means Vy is leading by Vx with 90 degree. So this phi will be 90 degree, right? Vy, we need to tell the angle by which Vy is leading Vx. So that is nothing but 90 degree, right? So in clock, that is why for clockwise it is 90 degree. Now you got the idea?
Yes, sir.
Okay, excellent. So let's take some problem, you know. Okay, so like assume we have two circles. Okay, let's suppose we are given with three circles. Okay, with amplitude, this is Vx, this is Vy, right? We are given with Vx is equal to mm, Vm sine 314t. Okay, we need to find out the equation of Vy. So can we write? Direction is also mentioned. Let me also give you the direction. Okay, so this is the direction given, right? So can we write the equation for Vy?
Yes, sir.
Yeah. What should that be?
Vm sine 314 minus 90t.
Vm sine 340t minus 90 degree. Okay. Do you agree, Mr. Reddy, with this answer?
No, sir. When it is at 0 degree,
Yeah, yeah. One by one, go ahead, please.
if we consider the origin, so
Uh-huh.
if the Vy has at 0,
Yes.
but Vx is at maximum, sir.
Okay, yeah. That's correct. Okay. So
So
what
that
should
means
be? Yeah,
that may be 180 degree shift, I think.
180 degree shift. Okay. So
हम ये बोल रहे थे कि वो माइनस नहीं प्लस 90 होगा.
+90. Okay, ठीक है, इसको +90 कर देते हैं. Still, so now I'll tell you one trick. Okay, not one trick. Just if once you have figured out the Lissajous pattern of one circle, okay, it will be same for no matter how many circles are there and wherever that is placed. Okay, you can shift your CRO values, right? You can shift your CRO waveforms. So that will not change your, amplitude or phase. But what will it change by making three circles? Or it is being changed in pattern. So amplitude should be same. Okay, phase should also be same that we have calculated for one clockwise circle. Since it is clockwise 90 degrees, so +90 is correct. But one more thing will change. What will be that? You did not focus on frequency. So now you have to draw tangencies here, right? Fx and Fy. So Fx by Fy will be how much? Vertical tangencies are 6, horizontal are 3, right? So Fy will be, sorry, horizontal is 2, only 2 tangencies are there, right? 1, 2, 2. So Fy will be 1 by 3 of the Fx. So this frequency will be 314 by 3. Okay. So frequency will change here. Okay. So any waveform you can bring to axis in CRO. Okay. There is no issue in that. Okay. So whatever locus has been derived for single circle at origin, that should remain same. Only frequency will change. How many circles you are able to see. In one time period, if you are able to see one cycle, which means its time period is, let's suppose for one cycle, if you are able to see in same time, okay, so let's suppose it is 20 milliseconds. Okay, now you are able to see three cycle, okay, three cycle in same 20 milliseconds. So frequency will change or not? This frequency is, Fx is 3 times of Fy. Okay, so frequency will change, right? So the new equation should be for this question, Vy will be Vm sin omega t. If the radius of circle remains same, then I am calling this Vm should be same. Sin omega t 314 by 3 t plus 90 degree. Okay, so that should be the answer for this problem. Any final question in this?
No, sir.
Okay, excellent. You got it, Mr. Reddy?
Sir, okay.
Okay. So that's it for today, and that's all for this course. So today was the last date, and this was the extra session, right? So we have already completed 12 weeks, and this was the extra 1 hour session, just additional. So I hope you are happy with the content. If any final doubt is there, you can let me know. Otherwise, we'll wind up the session.
सर ये क्वेश्चन था कि जैसे एग्जाम में थ्योरेटिकल पार्ट आएगा कि नहीं, कि टोटल ही मतलब ये न्यूमेरिकल रहेगा?
मोस्टली न्यूमेरिकल पे बेस्ड ही रहेंगे. मोस्टली ऐसा प्रॉब्लम विल बी बेस्ड ऑन न्यूमेरिकल्स, टू कैलकुलेट. So theoretically, questions are there, but they are expected to be very less. So just practice all the concepts with numericals. That is why all the weekly assignments are based on numericals. Very less theoretical questions are there, right?
सर ये पूछ रहे जैसे असाइनमेंट में जिस टाइप का क्वेश्चन मतलब प्रैक्टिस किए हैं लगभग वही सब रहेगा कि उससे अलग से बाकी कुछ है?
उससे थोड़ा थोड़ा सा एडवांस रहेगा. उससे थोड़ा सा और एडवांस रहेगा. But concepts will be same. थोड़ा सा maybe they might make question bit lengthy, so that it should be subjective type of questions.
अच्छा, लेकिन सर आंसर तो एमसीक्यू ही करना रहेगा ना?
Answer, you will have to solve the answer on paper.
हाँ, वो तो जैसे प्रैक्टिस जो हम बनाएंगे वो तो रहेगा ही कैलकुलेशंस वगैरह, लेकिन ऐसा तो नहीं है कि जैसे हम लोग रिटन एग्जाम में लिखते हैं पूरा एकदम उतना तो नहीं लिखना पड़ेगा, जैसे हम प्रैक्टिस वाला देना पड़ेगा ना रफ पेपर?
Yes, हाँ वैसे ही वैसे ही वैसे ही. This is your first NPTEL course?
यस सर.
Okay, yeah.
सर लिटिल बिट टेंशन.
No need to worry. You have studied everything, just practice numericals. Okay, all will be fine. Okay, you are getting all the concepts, right? So you will be able, it's just the matter of execution. So just go and execute it.
ओके सर.
Okay. Okay, then thank you very much for joining. Thank you very much.
थैंक यू सर.
All
Thank
the
you,
best
sir.
for your exam.
Thank you, sir.
Good night. Bye. So let's wind up the session. Bye bye.